gaskets. Yay! Welcome to the Naval Tech Tinker, and where we are building a jet motor, an outboard jet board for my son's jet boat. So in the previous episode I was playing around with these aluminium impellers that I have 3D printed, Chinese service for around 80 bucks. Turns out it cost me also 30 bucks extra in tax to import it, but okay. And right now I have worked on a lot of gaskets. So I have a new TPU gasket here to improve, to make sure that it's actually not leaking any grease. So here's the grease nipple. The grease goes inside here, makes this box watertight. And I have also added a new gasket. You can see that I have printed quite a few of these to try them out. And I also put on this nozzle, one here and one kind of here, to make sure that it's actually watertight, because I don't want water running out. So what I'm doing right now is to actually build everything together to make sure that I can actually test it in water. So I probably should epoxy paint this before, but I really want to test it in water today, so I'm not going to do that. I'd rather just dry it out later. So anyways, I'm gonna put this together, and I'm actually thinking about maybe I should work with the battery also. So I'm gonna have a 36 volt 210 amp hours battery to power this ESC. I think I'm gonna use this ESC. I was actually thinking about having the ESC outside of the box, but this works. This is 200. It's definitely not gonna pull that, so, or maybe it will. Let's see. The battery should handle it, no problem. And then we can run this. So yeah, let's get going. So first is this one on. Come on, not down with you. It's real tight, but that's good. And that goes against the ball bearing down there. And oh, damn it. Okay, well, let's see how this goes. And the water should come through there, so that's over. Let's turn around here. Let's see, come on, go down. Something's wrong. Yeah, let's see what it is. Turned out the screw is a bit outside, so it's kind of, when I rotate it, it kind of creates a mark there, but that just means it's super tight, so I'm going to be happy with that. And this one is now on. And then we put this one on. We need to align this one with the top there, so it actually can go down. Ooh, something like that. Yeah, let's keep going. And now that one is on. I just had it. This one clicks in place. And now the top nozzle. So something like, yeah, you can see the gasket kind of jumping out, but yeah, just need to align that better, like that. I'll have to do it with two hands. And that one is on perfectly. So the idea I had is to have a TPU gasket down here, because there was some wiggle room here, and I want to get tension to push this TPU really tight there, and also TPU here and TPU there, so the water wouldn't kind of splash out in different places, because water will be pushed up here, and then the pressure will make water flow back in here and go inside here, the box, so I can cool the motor. And as you can see, the ESC also has two on each side to cool it down. Lots of amps going there. So let's see if I can actually screw this together now with these. I had some issues last time, but let's try. I had to take it off and put it on again, and yeah, this one seems to have some issues, probably been damaged somehow, but yeah, I got it in. I think I cracked possibly the plastic a little bit when I pushed with a lot of torque. So, oh well, let's see. Let's continue and put it on. And here we go. So it is connected to a shaft, and it drives around. If you pull here, you can. So yeah, pretty happy with that. I'm just gonna have to figure out what to do next. So my goal is to get testing as quick as possible. So I need to order these bullet connectors for these. I don't have any with those. And yeah, but yeah, I can't really use them right now. I could kind of, they're kind of funny because they actually click in and I could tape them just for testing, which I'll probably do, but I'll order new ones and do this right. They're kind of exposed also, don't really like that. Not that it super matters here. It really does. Could be shorter, I could destroy the ESC. So I think I'll just leave this hanging inside like this for now, and then try to figure out if I can make a mount somehow. I mean, I could probably continue up on that one and put something here, or yeah, but it would be much nicer if I could actually put it against the wall here somehow. So yeah, the motor controller, which decides how fast this motor goes, needs to be here somewhere, which is cool. Then we could take that one straight from here, water coming in through the jet into the ESC, and then run it into, of course I haven't put that on, but yeah, let's put that on next. That's the water cooler, kind of water jacket around this motor. Let's do that. And that's what I thought. Yeah, so the thing is, this box is very tight here. As you can see, there's not too much sleeve here. So there's no way to get this one out right now without taking this one off. So if I'm going to redesign this, I should either take those away so that I can move this one a little bit out and just click it off here. I don't know if that's enough, but I am not going to do that now. The goal is to get it tested and see if it actually works at all. I think it absolutely does, but yeah, this one should probably be like 1 centimeter longer, and those removed. Their only purpose is to have those. You also create some rigidity in the box, this kind of shapes, but for now, yeah, that's I should have just clicked it down and it should come out here, but yeah, this is the life of product development. If anybody's showing you videos where they just put everything together and just poof, look how easy it went, that's not how this life looks like. It's try, fail, try, fail, try, fail again, fail again, fail again, fail again, and after printing lots of gaskets and whatever, or parts, yeah, you finally start seeing that it actually fits. Like, I'm gonna reprint this one too, because I can see that it's actually breaking there when I put a lot of torque in. So that one is a bit too thin, and I'm gonna went there, added 2-3 or 1 more millimeter around to make it stronger, and it's gonna hold up. But yeah, so now I have to take this off again after all this mess I had. It took probably 20-30 minutes, but there's no choice. This water jacket that goes around the motor, as you can see, it has rubber seals here, and water comes in, water goes out, and 20 more minutes or more. Let's try it. So I just wanted to show you that I actually made these bigger, but it's still too tight here. Or did I put on the wrong ones? Yeah, you can see I can't really grip it, and I don't have any, I mean, nothing, no tools to make this easier would go down there either around it. I could 3D print one, but yeah, I'm not out here to build tools. I'm here to get done with my son's boat before the summer. So I'm trying to focus on the right things right now. So anyways, I'm just printing another one of these out right now. At the same time, I'm printing a new one of these because it broke there. So yeah, constantly just finding small things out and improving. So tons and tons of iterations on things here. I have probably printed just this part 10 times, I would guess, and I'll probably print more when I have the steering here and I figure out this doesn't work. Looks okay in CAD, but yeah, CAD to reality how often is not that perfect, sadly. At least not the way I'm doing it. Maybe if you're better you can, but yeah, it's challenging. And just to show, I'm printing that part that mounts the motor, and it should take about 3 minutes, it says. And that's just amazing. These cheaty printers, they are beasts. And I'm at 40% speed. No, 50. So I could print this faster, but I rather print it a bit slower for, I mean, they hold up better if they're not super fast printed, but it's ABS. And I have this mega big 5 kilo ABS here. I totally recommend these, so you don't have like abrupt prints. I think it's Elegoo. Buy them for like $50 US, so prints become real cheap also, and it's really good to iterate. I don't have to constantly switch and change material, so super convenient. I doubt this will take 3 minutes. It's, let's see. Anyways, maybe 20. And it's finally off. Let's put that one on before we put the new one of these on, because you can see it kind of, I don't know if you can see it, but it cracked here. Yeah, you can see it here. So too thin, just print it again, and yeah, it's coming out probably in a few minutes, probably done before I'm done with this, so then I can start printing another one of those tops. It's really good to constantly do small improvements, as long as it doesn't really move things around, but make it easier to work with. That really helps out. Okay, before I put this on again, I want to see that I have actually connected these correctly. So in this tester, if I turn to the right, the motor should spin that way, and you can see that it would then push the correct way. That's not perfect exactly, but bear with me. So yeah, I can definitely feel it moving that direction. You can kind of see it too. So let's do some fun. Let's see how fast we can go. It jumps around. Okay, so I have taken out everything and I put on this water jacket, but I've also connected an RC receiver. It's a pretty cheap one. It's an hot RC, and I want to be able to go forward when I push this one. And I had a lot of time thinking about what, because I connected the battery to this one, so this is 5.8 volts, so that should be okay. And it turns out I needed an ESC connector, some battery to the positive and negative, which is the red and the brown there. So I had to steal the cable from one of these cheap servos and connect from the battery. Otherwise it wouldn't wake up. So if you have one of these and you want to try this, make sure that you have the battery. I mean, in a real setup we wouldn't use the battery. We would have a DC to DC converter taking the main power all the way here to here, and have a DC to DC converter. So this is top 42 volts down to 30, and then it would convert that to a straight 5 volt DC that would go into the ESC, and yeah, it would measure it, but also you would probably need to do some similar to this actually on this type of ESC where you don't have BEC. Okay, so what did I do then? Then I tried around which port did what, and yeah, on the second one, if I take this one now, and let's see here, so slowly, because yeah, you can drive this really fast. There's no load on this one, but I don't want it to. But you can also do the reverse. Reverse on a jet motor won't really work because, well, it's just how it is. It would just pump air backwards. But yeah, so this is cool. I can actually now put it in, and this is actually everything you need to control the whole one. So the idea is that I would have a servo, not this cheap little one. This is for small RC airplanes, but I'm gonna build something here that can control the nozzle over here. So it's time to put everything together. I also reprinted. You can see the old one looked like this. I took this one and I also make it really smooth in the printing. So the gasket will have a nice surface and that is flat against it. So time to put everything in and let's start trying this out. Started connecting the water. Okay, I mean, this is the exhaust of water. Then backwards it goes here, because yeah, from here to the ESC. So ESC might actually heat up the water before it gets there, which isn't optimal. But yeah, you know, yeah, I could probably split it 4 ways. Yeah, I actually have one. I have one of these, so maybe I could somehow get 4, 2 into that one and 1 into there, but then I would have to split again and go out. Let's see. Let's have some temperature gauge or something and just check out what happens. But the cool thing is, I have connected this now. So my neighbor came over and I just wanted to show him, so I just connected quickly everything and hoped it would work. And it does. So this is where we are right now. So isn't that just the coolest ever? Okay, so the day basically went and I'm done for today. So let's see it in action. So what I mean done for today is I have 3D printed a new one of this. I've 3D printed new gaskets. I have tightened this so it really is tight, and it has new gasket there, new gasket there. And there are a few things I want to test, and that is what happens if I run it and how it sounds. So let's see. There it goes. That one turned green over there. Ooh, look. Okay, let's go. It sounds. I don't know if there's an airflow here actually. Sounds like something is blocked there. So it worked for a while, but not now. Let's see what. So I don't really know what happened, but I could feel this one become super warm. I mean, the engine is turning, so something is blocking it for some reason, and I don't have a clue why. There should be absolutely nothing. It should just be one axle to the, or shaft, axle is Swedish, one shaft to the next shaft to this one. I mean, there is resistance in it, but there's a ball bearing there. I put a ball bearing in there and a ball bearing in here, so there's 3 in a straight line. Should be nothing, but should and is 2 different things. But that's where we're in today. So next time I'll problem solve that, and I see you probably next weekend. Cheerio.